How does the brain learn, predict, and recognize the world around us without losing its stability? Welcome to DeepVisus, where we peel back the layers of the mind to uncover how vision and cognition come together to shape our reality. In today's episode, we're diving into Chapter 5 of Conscious Mind, Resonant Brain by Stephen Grossberg. And our main question today is, how does the brain balance the need for stability and plasticity when learning and predicting the world? In this chapter, Grossberg takes us into the world of adaptive resonance, focusing on how the brain solves the so-called stability-plasticity dilemma. But what exactly does that mean? Let's break it down. When we talk about learning, it seems straightforward, right? We take in new information, store it, and use it later. But there's a problem. How do we learn new things without erasing what we already know? Imagine you're learning a new language. Every time you encounter a new word, your brain adds that word to your memory. But what if every time you learned a new word, it caused you to forget an old one? That's what Grossberg calls the stability-plasticity dilemma, the challenge of learning new things without disrupting previously learned knowledge. The answer, according to Grossberg, lies in adaptive resonance. The brain doesn't just indiscriminately add new information. Instead, it ensures that new knowledge resonates with existing memory traces. If the new information aligns with what's already stored, the brain integrates it seamlessly. If not, it resonates, and only when there's a match between the new and the old does the learning process take place. This is why learning feels stable, even though our brains are constantly adapting. But learning is just one part of the story. What about attention and prediction? How does the brain decide what to focus on? And how does it anticipate what's going to happen next? Grossberg argues that attention and prediction are inseparably linked. The brain is constantly predicting what will happen based on prior experience. When new input matches those predictions, attention is drawn to it. This is how we attend to important information in our environment while filtering out distractions. For example, when you see a familiar face in a crowd, your brain doesn't have to process every detail of that face, only the parts that stand out. Your brain is already predicting what the face should look like based on past experience. This process makes recognizing familiar faces easier and faster, because attention is automatically drawn to the relevant features. Now, here's the fascinating part. Grossberg's theory of adaptive resonance ensures that learning and prediction can happen simultaneously. When your brain predicts an outcome, it doesn't just passively wait for the event to unfold. It actively adapts and refines its model of the world. When predictions match reality, your brain strengthens those connections. If they don't, it adjusts its expectations. This is why, when you encounter something unexpected, your brain reacts quickly, updating its models and realigning your predictions with the new information. Now, let's talk about recognition. How does the brain identify objects, people, and situations in a rapidly changing environment? Grossberg shows us that recognition doesn't just happen by matching raw sensory data to memory. It involves dynamic interactions between top-down expectations and bottom-up sensory input. When you recognize an object, your brain is comparing the incoming visual data with a stored mental model of that object. This comparison is guided by both your expectations and the reality of what you're seeing. For example, when you reach for a cup, your brain is already predicting the shape and texture of the cup based on past interactions. If the cup is in a slightly different position or is a different color than expected, your brain adjusts its model to accommodate this change. This flexibility is part of how the brain ensures accurate and efficient recognition, even in the face of changing environments. So, how does the brain solve the stability-plasticity dilemma and handle attention, recognition, and prediction all at once? Through adaptive resonance. The brain learns by maintaining a delicate balance between old and new information, adjusting its predictions in real time, and ensuring that stability is preserved even as it adapts to new experiences. Adaptive resonance allows the brain to be both stable, preserving existing knowledge, and plastic, adapting to new information. It's a process that underlies everything from learning a new language to recognizing faces predicting outcomes, and even adjusting to unexpected events. If that got you thinking, then stay tuned. In our next episode of DeepVisus, we'll dive even deeper into the brain's ability to predict and process complex sensory information. We'll continue exploring Grossberg's groundbreaking work and how it all ties together in the fascinating world of cognitive science. Until then, remember, DeepVisus is where vision meets depth. Stay curious, stay sharp, and keep exploring the depths of the mind.